Okay, today we're going to be proving that the absolute value of x is continuous. And sorry there's no whiteboard today. I am currently on vacation around the time that this video is coming out. But we want to prove that the absolute value of x is continuous. And maybe I'll put right here, the first thing we should do is we should remember that if the limit as x approaches some number, let's just say a, of f of x, if that equals f of a, right? No matter what value of a, so for all a, then f of x is continuous. And I'll just abbreviate it so you don't have to see me write. And then now, we have to prove that this right here, the absolute value of x, and the limit as absolute value of x as x approaches a, is the same as this. So, we are going to have to use our epsilon delta definition. And if you haven't seen any videos on epsilon delta definition, I will just be going over it really briefly, so probably not the best place to learn. But anyways, the epsilon delta definition is for all epsilon greater than 0, there exists a delta greater than 0 such that if we have 0 less than absolute value of x minus a less than delta, then absolute value of the function minus the limit is less than epsilon. And so basically, what this all means is that this right here, we can just suppose all of this stuff is true, but then we have to check if this is true. So here's the deal. We are going to write down a P and an F, and then we're going to say, given epsilon greater than 0, choose delta to equal. What does delta equal? We don't know. We'll leave that for later, right? So just keep that in mind. And then if we suppose that 0 is less than the absolute value of x minus a is less than delta, then we have to check the absolute value of the function f of x minus the limit, absolute value of a. And then now we can see that we can just write this down one more time. Absolute value of x minus absolute value of a. And a can be anything, right? A is approaching x. Well, technically x is approaching a, but you know. And then here I'm going to remind you of something called the triangle inequality. So I will put right here, I'll make a note. If we have absolute value of x plus a, this right here is less than or equal to absolute value of x plus absolute value of a. So then I will put, maybe I'll just say, I'll put therefore the absolute value of x minus a is greater than or equal to absolute value of x minus absolute value of a. And then you'll see, this right here is actually called the triangle inequality, and then this right here is called the reverse triangle inequality. So there's a fun fact. And then you can see that, therefore, because of this, right, we can just do this in reverse. So the inside, this is less than or equal to the absolute value of x minus a. But what's absolute value of x minus a? Well, that is less than our delta right here. So then we have this right here is less than delta. And then at the end, we want to show that this is equal to epsilon, right? Because we already have our less than right here. So now we just need to show that this right here is indeed epsilon. So what we're going to do is we're just going to choose delta to equal epsilon. Yep, we can do that. So this is just equal to epsilon. And then now we see that we have shown that this right here is less than this. Or in other words, that it fills this condition. So this finishes our proof. So now just come down here and we'll write Q, E, D.